Hello, Chemistry 10HH student. This is Mrs. Altman. We are on video number 33, Types of Chemical Reactions, Part 8. Here are our objectives for today's video. Pause here. So in the last video, we learned how to assign oxidation numbers to atoms or molecules, and then today we'll be looking at applications of this. At oxidation reduction, we need to have something that oxidizes, and we need to have something that's reduced. Otherwise, we would have if we didn't have them paired together, we would have electrons being produced from nowhere or being taken away from nowhere. That would violate the law of conservation of mass. So to determine if something is oxidized or decreased, we have to take the oxidation numbers of all of the elements in the reactants and the products. If the oxidation state goes up, then it is oxidized. If the oxidation state goes down, then it is reduced. Pause here. Let's work through this. So the first thing we're going to want to do is we're going to want to get the oxidation states of all of the different substances. So we're going to start with AgNO3. So oxygen I know is going to be -2 there. Ag, because this is a part of a type 2, it's going to take its charge here, which is +1. I know this because the nitrate NO3 has a charge of -1. Then I'll just have to use a little bit of algebra to get the charge of nitrogen. We'll go ahead and fill those in. And then copper, I don't really need to do anything for. It's just 0 because it's on its own. And here I can see that in this case, silver is going to be 0 because it's on its own. Because nitrate didn't split apart, I could actually just assume that the oxidation states are the same. You could go ahead and do that work. And though here, the charge of copper is +2 because it's a part of something that's type 2. So I can see that silver and copper changed oxidation states, but the way that we actually answer the question is a little bit more involved. So first I'm going to say, yes, this is a redox reaction. So what is oxidized means the oxidation state goes up. So that's copper. That I could just say Cu is oxidized. But what's actually reduced, I can't just say Ag because it's actually Ag as a part of AgNO3. So you could either say AgNO3 is reduced. You can say the Ag in AgNO3 is reduced if that makes more sense to you. And because it's aqueous, you could say the Ag plus is reduced. But just saying Ag on its own is not the same thing because that's talking about elemental silver, whereas AgNO3 or Ag+, that's ionic silver, so it has very different properties. Let's take a look at a second example. And with the last example, if you didn't already recognize it, that's called a single replacement reaction. So without even having done the problem, I knew it was going to be redox. This is a double replacement reaction. I'm not going to say right now, but just because it's a double replacement reaction means I can already tell what type of reaction it's going to be. Or that whether or not it's going to be a redox reaction. I already had AgNO3 for the past one, so there is no need to do it again. NO3 stays together, so I know that those are going to be the same. Here, silver is again +1 because it's paired with something that's -1. And then looking at this, I'm not seeing any sort of change. So no, this is not a redox reaction. Pause here. So we'll talk more about this, but when metals dissolve, it's because they are taking on a plus charge. So that has to be an oxidation reaction. So if you have like solid iron sitting in some water, over the course of time, it will dissolve. And that is because that iron is oxidizing. Something in turn is being reduced. And then something that's going to be producing pure elemental metals from salt. So if you just have an aqueous solution, you run a current through it, and all of a sudden you see that there's some silver plating. That silver was reduced. So in order to be dissolved in water, it has to be oxidized, is the short. And to get it to no longer be dissolved in water, it needs to be reduced. Pause here. Here is just more applications of the oxidation states. So things that tend to make good oxidizing agents uh, are things that are going to be able to give away a lot of electrons. So you're often going to see polyatomic ions that contain metals with really, really high oxidation states, such as permanganate ions, because they're able to absorb a lot of electrons to allow other things themselves to oxidize. Reducing agents work a little bit differently. They're essentially electron donors. Rather than having things with very, very low oxidation states, what you actually tend to see would be elemental alkaline metals. So they really want to give their electrons away. That's a little bit less true for alkaline earth metals, so also true. And then hydrides and peroxides as well. That is all for today's video. Thank you so much for watching and have a great night.